Okay, this is year 10 notes. We're on unit 6 and we're doing a little bit of trigonometry. We've just finished doing Pythagoras theorem, so we're now going to be finding an angle using trig. So just a wee bit of the basics here then as we run through. This is a wee fancy angle here. You've maybe seen this before. This is a theta. You might just use an x if you want, but it symbolises the angle. It's a Greek letter, a bit like pi. If we have this angle here, we should be able to label our three sides. This one here, the longest one opposite the right angle, is always the hypotenuse. So we label it h. The one opposite the angle is the opposite, and the one adjacent, if you look up adjacent in the dictionary, it means beside. So the one beside, it's not the hypotenuse, then it's called the adjacent. And we need to be able to label our three sides depending on where the angle is. Say for example I draw another one here, just for an example, and my theta is here. We should know that the one opposite the right angle is the hypotenuse. The one opposite the angle is O, and the one beside the angle is A. One more quick one. Let's see. No, that's the same as the last one. We don't want that, sorry, apologies. Let's go for... Here's our angle here. The one opposite the right angle is always H. The one opposite our angle, if we're calling it theta, is O, and this one is A. If we know our two sides, we can then find an angle using 1/3 trig ratio. So sine theta is O over H, that's so. Cos theta is A over H, that's ca. And tan theta is O over A, and that's toa. And that helps us remember and then how we can work out our missing sides and angles. So let's take a wee look then at example 1. Find the missing angle in each of the following, giving your answer to three significant figures if required. First step I always tell people is we label our sides. The one opposite the angle is O, the one beside the angle is A, and the other one then, the biggest one, or opposite the right angle, is H. We look and see which two we have. So we have O and we have A, so we look back. Let's just bring this back up again. Which one has O and A? So it's going to be O and A, so it's going to be tan. So we're going to be using the tan formula. And our formula then is tan theta, as we have here. Some people use tan x, that's fine, is O over A. Tan theta is 8 over 5. And next is that is kind of strange move you've kind of seen in class. Theta is tan to the minus 1, 8 over 5. And we then put this into our calculator. So we get the inverse tan. If you look just above my tan button here, it's tan to the minus 1. So we get that. We're going to do that. And then it's 8 over 5. So you can do 8 divided by 5. You can do a fraction, 8 over 5. Either's good, whatever way you fancy doing it. So I'm going to do the fraction one. And then I close my brackets. No, I didn't want to do that. Let's try that again. I'm not good with calculators, I've got to say. 8 over 5. Maybe I'll close the bracket properly for us. And we end up then 57.99. So that's going to be 58.0 degrees. Again, your calculator might work slightly differently, but that's the plan. We sort of follow that step every single time. Let's try another one. Yes, this one's laid out slightly differently, but it's always the same format. The first thing we want to do is label our sides. The one opposite the angle is O. The one beside the angle, that's not the hypotenuse, is A. And then the longest one, or the one opposite the right angle, is H. So which two do we have? We have A, because we know it's 8. And we have H, which we know then is 17. So A and H, if we look and see, will be cos. So we would write cos theta is A over H. Cos theta is 8 over 17. And again, this strange move to work out theta. Cos to the minus 1, 8 over 17. And we put that into our calculator. So shift cos 8 divided by 17 with brackets equals, and our angle then is going to be 61.9. 61.9 degrees then is the answer to that one.